logs, and then we're going to look at inverse functions. This is as far away as I can get. Logs are actually exponents because we can write them as exponentials. Remember learning how to write logs in exponential form. How do you normally multiply with your exponent? Like if you're multiplying, what do you do with your exponent? You actually add them. Well, logs are like exponents. We have log base b of mn, where m and n are being multiplied together. Any ideas how we could make it into two logs? I want to separate them. Log base b of m. What would I do to separate them two? What do we do to our exponents here? So what are we going to do to our exponents? Add them. Because logs are like exponents. Does that make sense? Or if you have an addition sign between two logs, you can multiply the arguments as long as they have the same base. We have two separate logs right now. How could I combine them to make it into one log? To get log base a of what's 4 times 24. Does that make sense? Since they are being added together, you can just multiply the arguments, and now you have one log. You see how that works? How could we solve for x? How did Ronnie do that? What did she do? She said 24 equals x plus 4. Log base a equals 24 equals log base a of x plus 4. So 24 has to be the same thing as x plus 4. Does that make sense? If the two logs equal, they have the same basis. The arguments have to be the same. Does that make sense? So x would have to be. Any questions? Okay. How do we divide with our exponents? What do we do when we're dividing? If you have x to the 5th over x squared, that becomes x to the 30th. Is that right? So how would we rewrite log base b of m divided by n? Log base b of m minus log base b of n. Does that make sense? So if you have a minus sign between two logs, you're going to divide the two arguments. The one that comes first is the numerator. The one that comes after the division sign is the denominator. Does that make sense? Here's an example. What would we do first on this kind of problem? Combine these two, put them together. So make it log base 4 of what? 6 plus 6 divided by x minus 4. All of that is now your argument. Does that make sense? And it would equal log base 4. Any questions how you get to that part? What would you do next? Because log base 4 of this equals log base 4 of 5. So this big fraction has to equal 5. So x plus 6 equals 5x minus 5 by cross multiplication. 4x would equal 11. What would x equal? Does that work? Any questions on me? Okay. How do we, this is the last property for log. How do we raise a power with exponents? What do? You multiply these two together. Does that make sense? Any ideas what you would do with log base b of m to the n? Whatever. All of that. Does that make sense? You would. The log base b of m is like an exponent, and then the n is also an exponent. So you just actually multiply. Whatever you get for log base b of m, multiply by basically. Does that make sense? Y'all see how that works? Okay. Looking at another example. We have a 3 out front. You don't like having numbers out in front of your log to actually solve. So what would we need to do to that 3? Make it an exponent on what? On the x. log b's cancel, and so x to the third equals 8. So what would x have to be? 2. All right, real quick, grab your calculator, try and do log of some random numbers. What are y'all trying to plug in? Or what have y'all plugged in? 100, 10, 13, 50. What about negative numbers? Y'all tried those? Okay. For all negative numbers? Then obviously you can't try all of them. Are you all getting an error for your negative numbers? Okay, what about negative 1? Still an error? Okay, what about 0? Error? What about 1? It works? Yeah. Okay, what about log of a decimal? Like in between 0 and 1? Log of a half or a log of a point something? So some logs don't work, right? Logs of negative numbers. So if I had gotten, let's just say I got x equals whatever I actually got, and I also got x equals negative 10. Could I actually have negative 10 as an answer? If I look up here, negative 10 plus 6, is that a positive number? So x can actually be negative 10. Do you remember how like sometimes you would get answers on these kind of problems, x squared plus 2 equals 5 or whatever, you get numbers that didn't work. I remember you had to go back and check. It's the same concept with the logs. Sometimes when you do your algebra, you get possible answers that don't actually work. Okay, but if you'd gotten x equals 1, would it work here? But does it work over here? 1 minus 1 is 0. Log of 0, does it work? So the numbers that you plug in to your argument has to be greater than 0, like whenever you get your answer. So whatever it is, you have to go back and make sure that you can actually use it. Sometimes you'll get 2 answers, but only one of them actually works. Does that make sense? So just be careful that whenever you start doing logs, they probably won't introduce them for a few lessons where that happens. Be careful. Okay. All right. Looking at inverse functions. On your project, this is dealing with the very last question. You were supposed to draw a conclusion about the composition of inverses. It said, write what they did or whatever. Two functions are inverse functions if f of g of x equals x and g of f of x equals x. If when you compose the two, so normal function and the inverse, if they both equal x, they are inverse functions. Do what? Yeah, they just haven't told you that that means that they are inverse. Does that make sense? And I didn't tell you that on the project. I was hoping you might figure it out. Haven't checked. Haven't looked at it yet. But if you compose the two and they are actually both equal to x, then that means that they are inverse. Sometimes the problems will say show that they are inverse functions by computing their composition. Sometimes they will say determine if they are. If it says show that they are, that means that they are. Whether they are, these will be on your test. Either show that they are inverse functions or determine whether they are. The way that you get it correct, you show your work of computing their compositions and simplify them completely. Does that make sense? So f of g of x, what would we do for that? Instead of x, we put in 3x plus 9. Does that make sense? Go see how that works? So when we simplify it, we get so equals x. Does that make sense? Any questions on that one? So that's one of the compositions. We have to do the other composition too. So we have g of f of x. So what would we do for this one? Does that make sense? Wait, I did that should be. You see how that works? So what would we do when you simplify this? Which is x. Do they both equal x? So our answer is both compositions would be all of that. You'll see how that works though? Basically on these, your work is your answer. Does that make sense? If you just say f of x, f of g of x equals x, and g of f of x equals x, and that's it, you're going to get it wrong. Does that make sense? That's fine. Or see scratch work and circle it. Either one. Does that make sense? You're probably not going to have room to fit that in your right by the question. Any questions on these? Okay. So on this one, it says show that f and g are inverse functions. Are they going to be inverse functions? Because it says show that they are. It doesn't want to trick you. Whenever it says show that they are, it usually means they are inverse. Does someone want to go work f of g of x? Nobody wants to practice? You want to, Bailey? Okay. Agree? See how that works? It's 1 over x minus 3. So instead of x, we put in 3x plus 1 over x. Y'all see how that works? Does someone want to go write d of f of x? Okay, go ahead, Johnny. Do you agree with that? Y'all see how that works? Okay, so now what do we have to do? We've written the composition. Because it's 3 of x plus 1 over x. So you have to put it into both x. What do we have to do now? Simplify. Okay. Do you agree? 3x is canceled. So we're left with 1 over 1 over x, which is x. Does that make sense? 1 over 1 over x is the same thing as 1 times x over 1. You flip. Looking at this fraction, I'm going to rewrite this part first. Make it 3 over x minus 3 plus. Does that make sense? Then make it 3 plus x minus 3. Does that make sense? Which would become x over x minus 3 over 1 over 3. X over x minus 3 times x minus 3 over 1. Does that make sense? And then what? These cancel. We're left with therefore f of x and g of x are inverse functions because their composition equals x. Because, remember the symbol therefore? 3 dots? Since this is math class and not English class, we can use math symbols. We don't have to write out. Does that make sense? You can't use therefore the 3 dots in your English class. You could in your notes, I guess, but not on an essay. Yeah. No, I'm saying in English you wouldn't be able to use the little dots. But here you can. So this math symbol. Just like instead of having to write out 3, you write the number 3. Any questions on these?